So good evening all. So today I'm going to talk something about the statistics. So needn't to worry, I'm not going to talk anything about how to do a statistical analysis, or I'm not going to show you any numbers. I know many of our people in the biomedical field definitely will have some sort of aversion to the mathematics. Even I do have some aversion to the mathematics, but still, once the research comes, it becomes inevitable to do some maths. But before that, so when you start to plan the research, and you will go ahead with the preparation of research proposal, I have seen many people falter in the statistical analysis when they present it in the research committee, ethics committee. They present the statistical analysis, what they are going to do many times in a wrong manner. They don't know exactly what statistical test should be included for their research, particular research study. So this particular webinar, I am going to concentrate more on what statistical test you should select for your particular research study. I'm not going to tell how to do a statistics, how to interpret the results. So all these things I'm planning to deal in the next future webinars. But today, I'll make it very simple. Just how you can plan when you start your research study, how you can plan what type of statistics you have to do. So I'll just proceed with the next slide. Okay, so there are a lot of definitions. See, the statistics, it's a very vague term, to be very frank. There are a lot of definitions, but I selected this definition because it actually includes all the important objective of doing statistics for the research. So statistics defined as the science of collection, organization, and presentation, analysis, and interpretation of numerical data. So it is a science which deals with the collection. So how we are going to collect the data and how we are going to organize the data. After organization, how we are going to present it, and also analysis and interpretation. Many research work, we need this final part. It's a very important part, the analysis and interpretation of the numerical data. Okay, just coming to the importance, why we do statistics for research. So we can just do the research study, we can present the data, but why we have to do the statistics? So you all know, so whatever research work we carry on, we do in a particular population. So it may be a diabetes type 2 or type 1, a particular type of cancer patient. So this we consider as a population. But the thing is that you cannot select all the individuals from the population for your research study, because it's highly impossible because of the time constraint. The reason you cannot spend so much of money to do the research in the entire population. So normally a researcher will draw some sample from the population. So you draw the sample, you select the sample based on different criteria, and this sample will be subjected in the research study, and you will generate the data. Now, this data, you have to prove that it is a true representative of the population. Then only you can just justify your conclusion. So, to prove that it is the real, the results represents from the true population, you have to do the statistics just to prove that it is the true representative of the original population. So statistics become imperative. You cannot just avoid in any research study, because you have to finally prove that your sample, what you are subjected for your research study, is a true representative of population, and the conclusion what you draw from the sample can be applied to the whole population. So statistics forms a very important part. So you cannot decide the statistics at the end of the study. So when you start the study itself, you have to plan your statistics well ahead. Otherwise, once you complete the study, you may miss some part of data collection. So it is always wise enough to find out exactly what are all the statistical analysis you are going to perform once you complete the data. Okay, so when you want to decide the statistical analysis for your research study, you have to know some basic knowledge of certain things that are involved in your research study. So first thing what you should know is what is a variable and what are the different types of variable. And number two, when you identify your variables, each variable, what type of data it is going to generate. So that also you should have a thorough understanding. And finally, what type of study design is involved in your research study. So these three, if you could able to understand very well, then it's very easy for you to select a statistical analysis for your particular research study. Okay, so let us see something about what is variable. So I am planning for a research study. So first thing, when you plan a research study and start to develop your methodology, first thing what you should do is you have to identify what are all the variables present in your research study. So what is a variable? Say variable is some characteristic or condition that changes or takes on different values. Say for example, gender. It takes basically two values, even three values, but two values basically it takes male and female. Something if you take like height or hemoglobin level, that also takes some values. Okay, different values. Okay, so the variable is some characteristics or conditions. So you have to identify what are all the variables that are involved in your study. It may be a single variable, a two variable, or multi variable. So each variable you have to categorize. So when you start the study, you have to list down all your variables in your study. If you take most of the research study that involves mostly the relationship between a minimum of two variables, most of the studies, especially the biomedical research, most of the studies will looking for the relationship, some relationship between the two variables. So you have to identify what are those variables and what are the different types of variables you are having in your research study. So basically, if you see, most of the studies will have the two types of variables, that is the independent variable and dependent variable. So independent variable will create a cause, and that will that will produce some effect on the another variable. So that we call it as the dependent variable. Normally, if you take the independent variable, can be manipulated. Say, for example, you are doing some experimental study. You can manipulate some variables. So these variables only we categorize as independent variable, whereas the dependent variable will have some effect because of this manipulation, and this effect can be measured. Okay, so when you find out what is your variable, what are all variables you have, and after that you have to categorize your variable, whether it's going to be an independent variable or a dependent variable. So you have to categorize them initially, okay, as a independent variable and dependent variable. So for your better understanding, the independent variable will affect the change in the dependent variable. This is the way you can identify the variables, whether it is independent or dependent variable. Okay, this is a simple example. So this is a study wherein they want to find out what is the impact of the time spent sleeping with the test score. Okay, so you have two variables. One is the sleeping pattern in the night. The another variable is the score, the test score. So here you can see the sleeping, the sleeping pattern is the independent variable. Okay, so that causes and effects on the score. So the score becomes the dependent variable, and this varies based on the sleeping pattern, the independent variable. Okay, so likewise for any study, if you have two variables and you want to find a relationship between these two variables, you have to find out which one is the independent variable and which one is the dependent variable. So without this, you cannot decide what statistical test you are going to do. Okay, coming to the another important thing what you have to know in your research study is the data. Okay, so a simple definition of data is something measured in your research study. Okay, and your entire goal of statistics, after all, is to help the researchers to organize and interpret this particular data. So you are going to organize the data, you are going to interpret the data. So you should know what is a data and what type of data you have. Okay, so if you take data, it broadly falls either in scale or categorical. Okay, so if you take your variable, first thing what you have to do is you have to identify whether it is a scale or whether it is a categorical. Okay, and this scale again can be of two types, continuous and discrete. The categorical variable again can be categorized as the ordinal and nominal. Okay, so we'll see some examples and I mean understand what are these. Okay, right. So numerical, it will be in some numbers. Okay, so like age, weight, number of children, number of patients, a shoe size, so, I mean the hip size, waist size, all these things are numerical. As I said, it can be divided into two. It can be a continuous numerical variable or discrete numerical variable. Continuous numerical variable will have the numbers even in the fractions, but discrete will have numbers only in a either in an integer. Okay, so say for example, the shoe size, the number of children, or the number of patients attending a particular OP, number of patients attending a particular IP. So all these things will be a discrete numerical data. But on whole, you have to understand that the numerical or the scale, we call it either as a numerical or scale, falls in the type of, I mean, it is in the form of some numbers. Okay, categorical on the other hand, it will be categorizing the variables. So say for example, eye color. So it may be black or maybe brown, and gender, of course, we have categories like male, female, blood types. You know, there are 4 categories based on the ABO, blood grouping, ethnicity. So all these things are categorical data. Again, you should identify, once you identify that they are categorical data, you have to identify whether they are nominal or ordinal data. See, normally nominal data, you may not have any hierarchy, in the sense that there not be any ranking. Say if you take male and female, there is no ranking. The male may be 1, the female may be 2. See, when we code actually this nominal data, we can give any numbers. Coding while entering into the Excel sheets, you can give any numbers. I can give 0, I can give 1. So I can give any numbers, any orders. Okay, but when you go to the ordinal data, that will have some particular order. Say for example, pain severity, you have orders like 1, 2, 3. So you cannot code 1 as 3 or 2 as 1. So it has a typical order and you have to follow it. Okay, so these are the ordinal data, especially say the Likert scale. Normally we call it as one of the ordinal data, you know, the 5-point Likert scale. Okay, so these data we call it as ordinal categorical data. So once you identify your variable, then you have to just chart out each variable what type of data it is going to generate. So you have to just broadly classify them as scale or numerical, then categorical. Okay, this is the first task you have to do before deciding what statistical test you are going to do. Okay, the third important thing what you have to understand is what type of research study you are going to undertake. Okay, so broadly the research study may be either descriptive or analytic. Okay, so what is the difference between descriptive and analytic? Very simple. The descriptive studies will not have any hypothesis. It will not have any hypothesis. Analytical, definitely you will have some hypothesis. Okay, so descriptive, if you don't have hypothesis, there is only a chance of doing some survey or some qualitative research. You are not going to interpret anything out of the data. You are simply going to present the data in a qualitative manner. So mostly the surveys, the cross-sectional surveys, the questionnaire-based surveys is one of the good example for the descriptive study. But on the other hand, the analytical studies, they will have an hypothesis. So definitely without hypothesis, these studies cannot be conducted. So there will be some hypothesis. You know very well, once you identify the hypothesis, you will classify them as null hypothesis and the alternative hypothesis. So you have to prove. So once you do the experiment, I mean, you complete your research study, you have to prove disprove your hypothesis. Okay, so any study which has hypothesis we call it as analytic, and any study which doesn't have any hypothesis, we call it as descriptive. So when you start your research study, you identify the variable, then identify what type of data it is going to produce, and then identify what is your objective. If your objective is only a descriptive study, you are not going to have any hypothesis. So you want to find out in a particular population how many people have type 2 diabetes. It's a very simple descriptive study. Okay, it doesn't have any hypothesis, right? But if we want to find out how many people who take daily this many amount of coffees with the sugar have diabetes, and you will have some hypothesis that taking a 10 or more cups of coffee are going to take the patients are going to become diabetic. So if you have some hypothesis like this, so then it will be an analytical study, but you needn't to bother about the types of the study at this juncture when you decide about the statistics. So only thing you have to identify at this stage when you want to design what type of statistics you are going to do for your experiment is only descriptive or analytic. So once you classify as descriptive and analytic, then you can go ahead to decide what type of statistics you are going to do. Okay, so now we'll come to the statistics. What statistical studies we can select for our particular research study. When you take types of statistics, broadly it is classified as descriptive statistics and inferential statistics. So once you get a data, any study, that doesn't matter, you get a data, we call that data as a raw data. Okay, so you cannot present a raw data as such. I may be having a sample size of 300, 400. I cannot just put a table and put all these 300 and 400 data and present it to you. So I have to organize the data. Okay, so I can organize the data in different manners. I have to summarize the data, and also I have to present the data in an informative way. Okay, that is the initial part of any research study. Okay, so this part of statistics we call it as descriptive statistics, wherein you are not going to infer anything or this data. With the data you are not going to conclude anything. Okay, but when you come to other part of the another type of statistics, we call it as inferential statistics. In this you determine something from a sample drawn from the population. Okay, so all studies which has hypothesis, you will be performing inferential statistics. Okay, so now you have your study design. As I told, you have descriptive and also the analytical study. So if it is a descriptive study, your study is only a descriptive study, then you have to perform only descriptive statistics. Okay, so your study is only a descriptive study, then we have to do only the descriptive statistics. Suppose your study is an analytical study, then you have to do the descriptive statistics as well as inferential statistics. Both will be involved in the analytical study. Okay, so whenever you present your research study, I have seen some IRCs, I have seen people submitting the papers. Okay, the research study, wherein for descriptive statistics, they have mentioned all these p-values. They have mentioned what is their significance level and all these things. Okay, so these things clearly tells that the researcher has not have any idea about what is a descriptive statistics and what is inferential statistics. So whenever you do a descriptive research study, so you have to be very clear that you should not include any inferential statistics as the method what you are going to adapt. So simply you have to stick on only to the descriptive statistics. So you'll see what are all the things you can do under descriptive statistics. So normally descriptive statistics we measure in the form of frequencies, or we'll do some basic measurements like say blood pressure, etc., etc. So you do basic statistical analysis, and you will organize and present it. Okay, in inferential statistics you do a lot of things like you do a hypothesis testing. That's what I told. Whenever you design an analytical study, you will have an hypothesis. So it is your final conclusion. You have to find out whether your hypothesis, whether null hypothesis is correct or alternative hypothesis is correct. Sometimes you like to find some correlation between two variables. Then you will find the so-called confidence intervals. All these things I'll deal in my next lecture. Then significance testing and also some predictions. So all these things comes under the inferential statistics. So basic is the hypothesis testing, okay, and also the correlation in the studies where you would like to see some correlation between two variables. Okay, so let us see what are all the statistics available under the descriptive statistics and the inferential statistics. Okay, so when the descriptive statistics comes, you have frequencies and percentages. Okay, so I will find out a particular variable. Under particular variable, what are all the categories you have, and what are all the frequencies of these categories, and that I can convert it as a percentage. Okay, suppose I measure some values, I can take a mean and standard deviation and I can present it. Okay, so but very important thing is the frequency and percentages. But most of the times the descriptive statistics will, the outcome of the descriptive statistics will be the categorical data. Okay, so if your descriptive study has some numerical data, then you can go for the mean and standard deviation. Otherwise, most of the descriptive studies, I have seen that the data will be mostly categorical data. So in that case, you'll be calculating the frequencies and percentages. As far as the important inferential statistics is concerned, we have the correlation studies, the correlation statistics. Then we have a very popular test called t-test, student t-test. Then you have the chi-square, and logistic regression is also nowadays gaining very important place in the biomedical research. Okay, so before going into the going and seeing into the different types of statistics, you have to understand the terminology univariate and multivariate analysis, because most of the statistical packages will have, it will put a question to you whether it is a univariate or multivariate analysis. Suppose you are going to deal a variable one at a time. So just you take one variable and you are going to organize and summarize it. Then it is a univariate analysis. And multivariate analysis, we examine the relationship between two or more variables. So you take two or more variables simultaneously and analyze it. Okay, if you analyze these variables together, maybe two or more, we call it as the multivariate analysis. If you analyze the relationship between two variables alone, we call it as bivariate. Okay, so these terms you can see inside the statistical packages. So you should understand this terminology, what is univariate analysis and multivariate analysis. So univariate analysis pertains to the descriptive research design. Okay, when you come to the analytic, mostly it will be multivariate analysis. Okay, so this also very important term. Okay, so descriptive statistics. So as I told, it's a univariate analysis. So normally the frequencies, the counts, okay, and also these frequencies can be expressed in the form of percentages. Okay, so the categorical data, especially the nominal data, even the ordinal data, that doesn't matter, you can present it in the form of frequencies and percentages. If your variable in the descriptive research study, if your variable is a numerical or scale, if it is in scale, you can very well do the mean and standard deviations. Okay, so these are all the important descriptive statistics you can do in your research study. But before that, you have to identify what type of variable you have, what type of data it is going to produce, and what is the aim of your study. Okay, so these are all the different ways by which we can present the frequencies and percentages. So here, this we call it as a frequency table. So you can present in the form of a frequency table, or you can present in the form of a pie chart or a bar chart. But one thing you should understand, whenever you produce a research paper, any one representation alone is permitted. I have seen people putting putting the multiple representation of the data in the papers. One single analysis, they'll put both the table and pie chart or table and bar chart. So that is not permitted in any research article. So this you should understand at this juncture. Only one type of representation is only allowed in a paper. So most of them prefer these tables, which will be easy because it will represent directly in the form of numbers. Okay, pie chart and other things you can put, but basically for gender or age group, we use pie charts. But otherwise, we go for this frequency chart, because this will give the numbers directly. It's easy for us to interpret the, or easy to identify, okay, the frequencies and the percentages from the data. Okay, unlike the bar charts wherein I have to go and take a lot of time to read the data in it. Okay, this forms a very clear and lucid presentation of the data, the frequency table. Okay, sometimes you'll be like to put the distribution scores. So you have a lot of plots like scatter plot, box plot, box and whisker plot, histograms. So this will help to find out what is the distribution of the data. Okay, so now coming back to the inferential statistics. So we saw how the descriptive statistics is done. So we'll see about the inferential statistics. So the inferential statistics can be used to prove or disprove the theories. That's what I told. Whenever you have an hypothesis, you have to either prove or disprove it. So you will classify the hypothesis as null and alternative. So you will prepare the null hypothesis of your study as well as the alternative hypothesis of the study. Most of the times I have seen you will be very keen to support your alternative hypothesis. So to do this, you have to do the inferential statistics. So you have different type of inferential statistics like correlation, t-test, chi-square, and logistic regression. So you have to find out what type of data you have. So you have to find out the data, and based on the data, you have to find out what type of test you have to do. So that's what we are going to see now. Okay, so we'll start with the correlation and regression. So correlation and regression analysis is normally done when you are interested to find out the relationship between the two quantitative variables. Okay, so I want to find the relationship. Say if I'll give you some examples in my next slide. And what you finally do is you develop a linear regression equation. Okay, so this is what finally done. And this equation sometimes helps to interpret the unknown values. Okay, so in the correlation study, basically you will be interested to see the relationship between if one variable increases, whether the other variable increases or decreases. So this is what you are going to do in the correlation studies. So when you prepare the correlation chart, you will get something like this. Okay, so you can see in the first chart the line. Okay, so all the data are following in a straight line. Okay, and in this direction it means it is positively correlated. If it is in the opposite direction, it is negatively correlated. But we calculate the so-called correlation coefficient. Okay, we call it is represented as a small r. This correlation coefficient value will tell you what type of correlation you have. See, normally the correlation value, if the r value is between 0 to 0.25, little or no relationship. That's what we conclude. 0.25 to 50 we say fair, and 50 to 75, 0.75 we call it as a moderate, and 0.75 to 1 we call it as a strong relationship. And if you get a value of 1, it is a perfect correlation. So this statistical test will help you to find out what type of correlation the data, two variables have. Okay, so many times I have seen the researchers in biomedical research, they will looking for this particular type of hypothesis. They would like to know whether one variable influences the other variable. Okay, so this is what the statistics you have to choose, and you have to finally find the so-called coefficient, correlation coefficient, and find out the R value, and how to find out the relation. If the R value is in the plus sign, it means it is positively correlated. If it is in negative sign, we take it as the negatively correlated. Okay, so that's what how to interpret. I don't want to go in depth. Okay, so if the relationship is in the same direction, okay, it is called positively correlated. It means that if one variable increases, the other variable also increases. If the independent variable increases, the dependent variable also increases. If it decreases, the dependent variable also decreases. So this is what we call it as the positive correlation. On the other hand, the negative correlation, the heart rate. So we give the example as heart rate tends to be lower in the person with the exercise frequently. So more the exercise, more will be the, less will be the heart rate. So the so negative, it is negatively correlated. So what we see is that the correlation value, the R value will be in the negative side. Okay, so this is what we see in the correlation statistics. Okay, so whether the variable in the same direction, both the variables are in the same direction or in the opposite direction, and also whether we can, even you can prove that there is no correlation at all. Okay, so this is what done. So whenever you study your hypothesis is to compare two variables and see whether one influences the other, okay, then we can do this correlation test. Okay, now say many times many of your research study will involve comparing the means. You will take two variables and the two variable mean may have some difference. You want to know whether the difference is a real difference or by chance. Okay, so the comparing mean, so your research design has the mean comparison of mean value, then your statistics, what statistics you have to do, that's what you have to see now. Okay, so if you are going to compare between the groups, two groups, say I want to compare between the male and female. Okay, then that's one example I am giving. So if you want to compare between the male and female, so we do the test called the independent t-test if you have only two groups. Okay, so I want to compare the mean, okay, between two groups, then the two it contains the two group, then you go for the independent t-test. If you have more than two, 3 plus, then you go for the one-way ANOVA. Okay, ANOVA stands for analysis of variance. Okay, then within the same subject, okay, not the group but within the same subject. Okay, say for example you are giving a drug to a patient to see whether the anemic status increases after the administration of drug. Okay, so what you will have two data. One is before drug, another one is after drug. Okay, if you have such two data before and after, then you do a paired t-test, but you are going to see for a prolonged period of time. Say for example you are administering the drug and seeing the anemic status, and you are seeing for 1 month, 2 month, 3 month, so it becomes a repeated measures ANOVA. Okay, so this is very important table. So you have to identify what type of hypothesis you have, what type of data you have, and you want to compare the mean. Okay, so then you have to select the appropriate test. Okay, so let us see in detail what are all these tests. Okay, now let us start with the t-test. Okay, so this t-test will tell you the significant whether the mean difference between the two groups or two comparison groups, whether the difference in the mean value is statistically significant or not. Okay, so any research when you do, the mean values will have some difference, but your duty is to find out whether the difference in the mean is by chance or a real difference. So you do a statistical test and find out whether the difference in the mean values between the two groups are statistically significant or not significant. Okay, so as I told, the t-test involves only two groups, comparison of two groups, and depending upon the type of groups, you will select either the paired t-test or the independent t-test. Okay, so all these things you would have seen, like the p-values greater than and lesser than, and how we interpret the significance. So this I will take it in the next lecture. Okay, the paired t-test. So as I told, the paired t-test, you will compare the means of a continuous variable in two non-independent samples. Okay, you will not have two groups, but same people before and after. You will take a before and after. So here the example is the diet X, whether it is effective in lowering the serum cholesterol. So you will provide the diet, and you will look into the looking after some period of time and measure the cholesterol level. So before the diet X, what is the cholesterol level? After the diet, what is the cholesterol level? So the hypothesis maybe the null hypothesis may be that the level never changes. That is the null hypothesis. And alternative hypothesis, they say that the level will be either lowered or increased. So you will have two hypotheses. So to prove this, you have to do a paired t-test. Okay. On the other hand, the independent sample t-test, you will be comparing the mean between the two independent samples. Okay, the variable will be single variable, but it will have two categories. Okay, two independent samples. So it will be two groups of the people. Okay, so in that case, you will be going for the independent t-test. Okay. Okay, for independent student t-test, what are the assumptions? So what should be the assumption in the sense, what are all the things you have to see and find out whether the independent student t-test should be selected for your research design. First thing, your dependent variable should be measured in a continuous scale. Okay, so now you identified that you are having two variables, independent and dependent. Okay, so the dependent variable should be in a continuous scale, and your independent variable should only have two categorical categories. That is, it's a categorical data. Okay, your independent variable should be a categorical data having only two categories. Okay, so when you design your research study and you find out that the dependent variable is a continuous scale and your independent variable is in two categorical manner, say male, female, or something like that, you will be selecting, and your objective is to compare the mean value. Then you have to go for the independent student t-test. On the other hand, if you want to go to the paired student t-test, so you'll be say assumption will be your variable should consist of say related groups. Okay, so your variable should contain the two related or matched pairs. Okay, and both the variables should be in continuous scale. It's very, very important. Okay, now coming to the ANOVA. So as I told, if you have only two groups or two matched pairs, you will go for this student t-test. But when it goes beyond two, say 3+, then you will go for the test called ANOVA. Again, comparison of the means. Okay, mean values. Okay, so here you will have a dependent variable. Okay, that will be in the continuous scale. Okay, continuous or scale. It will be having some numerical values. Whereas the independent variable, it will have categories more than two. Okay, so the independent variable will be a categorical variable more than three categories or two categories, 3+, and your independent variable will be in a continuous scale. Okay, so you will be proving that either proving or disproving the null hypothesis. So this will be the objective. Okay, your null hypothesis states that the mean 1, mean 2, and the mean 3 are equal. Okay, so this will be your null hypothesis. But most of the times in our research study, we like to disprove the null hypothesis that the mean has some difference between the different groups. Okay, so there is a there is a so-called post-hoc test. When you do 3 or more groups, independent groups, you would like to know how the mean values differ from between the different groups. So I have 3 groups. So I can compare by doing a post-hoc test. I can compare between the group 1 and 2, 2 and 3, and 1 and 3. Okay, even though you may get a significant result for the ANOVA, you have to do a post-hoc test and find out whether there is how the values are significant between the groups. Okay, many researchers will be interested to do that. Okay, sometimes I have seen there will be some disparity in the between the groups. Some groups there will be a significant difference. Some group it may not have a significant difference. Okay, so whenever you select the ANOVA test, you have to tell what post-hoc test you are going to do for that ANOVA. So normally the Tucky is one of the popular tests, then Schiff's test. Okay, so normally I perform Tucky's test. It's quite easy to interpret. So here you can see the example of the Tucky test. So here you can see there is a comparison between the groups 1 and 2, 1 and 3, 2 and 1, 2 and 3, 3 and 1, and 3 and 2. It gives the value, significance value for the each group. See, 1 and 2, it is not significant, but 1 and 3, it shows significance. Okay, similarly, the 2 and 2 and 1 and 2, 1 and 2, same values only you will get. Okay, so here you can see 3 and 2. Okay, again, it is significant. Okay, so this Tucky test will tell you between the groups what are the significance. Okay, whether the mean difference is significant or not. So whenever you decide to do ANOVA for your research design, you have to also mention what post hoc test you are going to do. Okay, ANOVA, you have different types, again depending upon the type of your variables. Okay, so normally you would have seen the one-way ANOVA. This is one which normally we perform because most of our data will fall under this analysis. Okay, so in one-way ANOVA, that compass the mean of 2 or more independent groups. So you will have one independent group and one dependent group, and the independent group will have 3 or more or 2 or more independent groups. Okay, among this independent variable, we will have groups. Okay, 3 groups, 4 groups, like that. Okay, so we will perform the so-called one-way ANOVA and find the significance in the difference. Okay, and you have another ANOVA, we call it as two-way ANOVA. So here you can see the table. You can here see 2 independent variables. One is diet, another one is gender. You want to see the influence of diet as well as gender on the weight loss, whether any influence in the diet, okay, that correlates with the gender, and you have the weight loss. Okay, so this type of data, when you want to compare 2 independent variables with a one dependent variable, okay, and the assumption is that the independent variables, the 2 independent variables should have a categorical data, okay, and the weight loss, that is the dependent variable, here it is the continuous or scale. Okay, so if your data falls into this category, then you will select the so-called two-way ANOVA. So you have to tell in your research proposal that you are going to perform the two-way ANOVA to find out the hypothesis. Okay, what is the significance? Okay, so to simplify, to the dependent variable here, the example what I showed is the weight loss, and the independent variable are diet and gender. So you will test for these things, like mean weight loss does not differ by diet. There is null hypothesis. Mean weight loss does not differ by gender. There is no interaction between the diet and gender. So this is what will be your main objective. Okay, so you will see for this, and then finally you will do a two-way ANOVA to find whether the diet and gender together has any interaction and influences the weight loss. Okay, so if this type of hypothesis you have, and if you have this type of data set variables, then you have to go for two-way ANOVA. And another interesting ANOVA is the repeated measures ANOVA. It's a variation of the paired t-test. Okay, in the paired t-test, you have only 2 variables, matched variables between the same patients. Okay, you do before and after. But if you do continuously like this, say you do before, after 4 weeks, and after 8 weeks, so then it becomes a repeated measures ANOVA. And also the repeated measures ANOVA also have a comparison. You can also do a comparison between the 2 groups. Okay, so another independent variable also you can bring inside. Okay, here you can see the example. You can bring an independent variable and you can compare, okay, between these 2 independent variable, how it influences the cholesterol level in a period of time. Okay, so little complicated ANOVA, but if your objective contains such data, okay, then you have to select the repeated measures ANOVA. Okay, another interesting test and popular test you would have heard in many papers, or you have seen in the many paper research articles, that is the chi-square test. You have to pronounce as chi-square, but I have seen many people pronouncing it as chi-square, chi-square and all. Just you have to pronounce it as chi-square. So when we use, very simple, you have 2 variables. If both the variables are categorical variable, okay, both your variables are categorical, then You have to go for the chi-square when you want to see the association between these two categorical variable. Okay, so I want to see the association between two variables, and both the variables are categorical variables. Okay, so this is one example. Okay, I want to know whether the smoking is related to the lung cancer, or I want to know the obesity, whether it is related to diabetes. Okay, so we do a test like, we select a study design like a case control or cohort study to do such to prove such hypothesis. We'll always select these two type of research design. So in that case, you will prepare a table. This table we call it as a contingency table or cross tabulation. Okay, so this is a very popular representation of this data. We call it as a cross tabulation or contingency table, and then you will subject this to the statistics. Okay, that is the chi-square test. Okay, so another interesting thing, the chi-square requires at least a value of 5 and more in each cell. Okay, you can see A, B, C, D. Each cell should have a value more than 5. If you have less than 5, including a 0, the chi-square cannot be performed. Then you have to go for another test called Fisher exact test. Okay, so when you do manually, so you are performing a chi-square manually, when you get a table, contingency table, if you have any values less than 5, then you should not do a chi-square test. You have to go for the Fisher exact test. Okay, so initially when you go for a research proposal, you may not know what values you will get. So you can normally put a chi-square. Okay, you can put a chi-square and proceed with their research. But after the data comes and you prepare a contingency table, then if you find if there are values less than 5, then instead of chi-square, you have to go for the Fisher exact test. But you needn't to worry when you go for a statistical packages, not manual. When you go for a statistical packages like SPSS, when you perform the chi-square, if the values are less than 0 in any, less than 5, automatically the SPSS will shift from chi-square to the Fisher exact test. It will not ask you, simply it will shift it, and then it will tell us that it has performed Fisher exact test because of the reason that the value in such a well and such a cell, it is less than 5. Okay, so automatically it will adjust the test. Okay, so another important variation in the chi-square is the McNemar test, like Fisher exact test, McNemar test. Most of the times people wrongly perform chi-square in place where they have to do the McNemar test. Say I want to see the knowledge level before I'm going to do some teaching or coaching to some students. I want to see whether any knowledge is changing after that interpretation. Okay, so I am showing some education videos, or I'm giving some interpretation in the form of some lecture. I want to see before lecture what is the knowledge level, and after lecture I want to see the knowledge level of the students. Okay, so in that case again I will get the 2x2 contingency table and find out whether that knowledge is really increased or not. Okay, so that case I have to use McNemar test, not the chi-square test. If your study output, you are seeing before and after, okay, then you have to see for the when you have to go for the McNemar test. And also in the diagnosis, normally see if you are bringing out a new diagnostic test, okay, and I will be comparing my diagnostic test with the gold standard diagnostic test. So same sample I will subject both for the gold standard as well as the new diagnostic procedure. Then I will find out whether it is positive in the gold standard and whether it is positive in the diagnostic test, new diagnostic test. Okay, so this you will get this sort of table. So wherein, say for example, here positive, you can take it as the positive both in the gold standard. So this rows are the gold standard and the columns will be the one which will be a new diagnostic test. So positive means it is positive both for the gold standard as well as the new diagnostic test. Positive, negative, it means it is positive in the gold standard but negative in the the new diagnostic test. So like this, you will have a 2 into 2 table, and the difference what you get, you have to prove that it is significance only by the McNemar test, not by the chi-square. So many people falter here. So when you have a research proposal involves such comparison, so you should not put chi-square. Please use the McNemar test. Okay, finally, the logistic regression is quite gaining popular for many reasons, because it is used for nowadays for even standardizing the questionnaires. Okay, so logistic regression is basically, if you see the normal regression, so both the data will be continuous. Your both the comparison data. So I said in the regression or in the correlation studies, you will see for the you see for the correlation of two variables, one increases if others also whether it increases or decreases. So this is what you see. So both the variables in the linear regression or the correlation, both the variables will be in a continuous scale. But if you have data, say, wherein the dependent variable or categorical variable, your dependent variable is a categorical variable and your independent variable is the in the form of continuous scale. Okay, then you will go in for a regression called logistic regression. So just we can see an example here. So a study wherein the survey is conducted between the adults who are referred to the sleep clinic. So they just see the severity index with the presence or absence of hypertension. So here you can see the severity index is the independent variable, which is a continuous data, and this is a dependent variable, whether the hypertension is present or not. This is the dependent variable, and it is in the form of a nominal data. Okay, so categorical data. So you have to perform the so-called logistic regression. The logistic regression is also used to find the confounder variables. So, so the logistic regression itself deserves a special lecture session, but I'll make it very simple. When you have two variables, the independent variable and the dependent variable, and you want to compare it, and if your data, say if it is absence or presence in the dependent variable, or it is in the categorical data, the dependent variable, and your independent variable is in the form of a scale, then you will go in for this logistic regression. Okay. Okay, so finally, to conclude, just this I am leaving to the audience. So he has done, this boy has done a statistical analysis. So just tell me whether it's correct or wrong. Audience can unmute the participants.
Yeah.
Correct or wrong?
There are many participants, so I'll guess you'll get correct answers.
But they should take time. They should not jump into immediately.
They'll not jump into conclusions and give wrong answers like me.
Is it correct or wrong? Who is going to answer?
Wrong.
Wrong. Okay. So this boy thinks that his study is out. He has done a small statistics, and he thinks that he's going to win the president election in the math club. Unfortunately, he's going to lose it.
51% of 200, right?
Yeah.
Not 51% of 100, right?
Yes,
Okay.
yes. He has to actually take the average of 51. He has not done that. So what